Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. This is problem number 4 from the last exam MLC written answer section and an exercise for exam LTAM for July 12, 2018. XYZ Insurance is conducting a profit test of a fully discrete participating whole life policy with a death benefit of $100,000 issued to a life age 80. XYZ holds net premium reserves for this policy. You are given the following information about the reserves. The reserve basis is the illustrative life table with interest at 6%. KV denotes the net premium reserve at time K. 1V equals 4263. Part A of the question is to show that a 2V is 8450 to the nearest 50. You should calculate the value to the nearest 1. For the profit test, you are given the following additional information. The gross premium is $13,000. Pre-contract expenses are $1,000. Percent of premium expenses are 20% in the first year and 5% thereafter. Maintenance expenses are $75 at the beginning of each year, including the first. The interest earned on insurers' funds is 7% per year. Mortality rates are 85% of the illustrative life table rates. Policy lapses will be 20% of policies in force at the end of the first year and 5% of policies in force at the end of all subsequent years. The cost surrender values are 20% of the reserves. Cash dividends equal to 70% of the pre-dividend profits in any year are distributed at the year end. If the policy generates a loss in the policy year, no dividends are paid. Dividends are payable with respect to all policies in force at the beginning of the year. PRT denotes the profit emerging at the end of the teeth year after distribution of dividends, given that policy was in effect at the beginning of the teeth year. PR1 equals 265.72 and PR3 equals 894.99. The risk discount rate is 10% per year. Part B show that PR2 equals 820 to the nearest 10. You should calculate the value to the nearest 1. Part C, calculate the partial net present value up to time 3, NPV3, for the policy. Part D, now assume that at each year end, for policies remaining in force, the dividend is distributed as a reversionary bonus. The additional death benefit is calculated using the reserve basis and the equivalence principle. Part 1 of Part D, calculate the additional death benefit purchased for a continuing policyholder at the end of the first year. Part 2 of Part D, show that the revised value of PR2 is 830 to the nearest 10. You should calculate the value to the nearest 1. Part E of the whole question, explain why PR2 increases when the dividend is converted to an additional death benefit. For Part A, we calculate the reserve, the net premium reserve at policy duration 2, using the annuity ratio formula, because the illustrative life table and 6% interest are the assumptions for the calculation. So 2V will be simply equal to 100,000 times 1 minus A.82 over A.80, which we look up in the table as 5.4063 and 5.9050. And after we do the calculation, this comes out to be approximately 8,445.39. For Part B, let us denote by PR2 minus the profit before the distribution of dividend. So it equals to the previous reserve at time 1 plus premium after expenses, all this accumulated with interest earned on the funds, which is 7%, minus a payout of death benefit for those who die, and minus a payout to those who withdraw, which is 0.2 times the reserve at policy duration 2. And what remains for those who survive is the reserve at time 2. Let decrement D refer to death and W to lapse, of course, in this formula. So we have mortality is 85% of illustrated life table. We look it up, and it comes out to be 0.074494. Lapses are 0.05 times 1 minus the probability of dying, so of those surviving 5% lapse, and that's 0.04627553. And surviving policies, that's 95% of those surviving, and that's 0.8792307. And then we plug in those values, and we get PR2 minus to be 2,742.66. Now, if dividend is 70% of this amount, then that's 0.7 times the amount we just calculated, and that's 1,919.86. The retained profit is profit minus a dividend, and that's 822.20. To calculate the net present value at time 3 for this policy, we will need to calculate all profit measures through time 3. So the initial setup cost is 1,000, so the profit at time 0 is negative 1,000. Profit at time 1 is 265.72. Profit at time 2 is for those who survive times the PR2 measure, because we doing the calculation from the perspective of the initial date of the policy, so that's why we multiply this by the probability of survival, and that's 613.31. And then pi 3, profit measure for time 3, is probability of survival over 2 years, and that's probability of survival from age 80 and then from age 81, times the profit measure that we calculated at time 3, which was actually that was given, so that we used that profit measure of 894.99, and we recall that we using the 85% of the illustrated life table for mortality. So we plug in all these values and we get 586.55. And the net present value is all these profits adjusted for probability of survival, then discounted at the risk discount rate, which is 10%, and this comes out to be 189.12. For Part D, we assume that at each year end, for policies remaining in force, the dividend is distributed as a reversionary bonus, so it is used to purchase additional insurance coverage. The additional death benefit is calculated using the reserve basis and the equivalence principle. So we calculate the additional death benefit purchased for a continuing policyholder at the end of the first year. Note that after dividend profit at time 1 is 265.72, and that amount constitutes 30% of the profit because the dividend was 70% of the profit. Hence, the total pre-dividend profit was 265.72 divided by 0.3, or approximately 885.733, and so on. And the dividend amount available to purchase additional life insurance coverage is 70% of that, so 0.7 times the amount we calculated, or simply the difference of the two, but it's 620.01333, and so on. We look up A81 in the illustrated life table to be 0.68, and based on this, additional life insurance coverage purchased is that 620.01 divided by 0.68 approximately, and that's approximately 911.78. Now we calculate the revised value of PR2. Note that the additional reserve at time 1 due to reversionary bonus is 620.01 because this is the additional actuarial present value of future benefits and the actuarial present value of future premiums is unchanged. And of course the basis for the reserve is the illustrative life table and 6%. On the other hand, at time 2, the additional reserve is the actuarial present value then of additional death benefit of 911.78, which is 911.78 times A82 looked up in the illustrative life table, which is 0.69398, and this comes out to be 632.76. We now use these additional reserves created by the reversionary bonus in the calculation of adjusted, indicated with a star, pre-dividend profit at time 2, so PR2 minus with a star, is, well, initial reserve is now 4263 plus 620.01, plus premium after expenses, accumulated at 7% interest rate earned by the company, minus death benefits for those who die, withdrawal benefits for those who withdraw, minus for those who survive, the reserve at the end of the year. And this comes out to be 2,775.95. The dividend is 70% of that, and that's approximately 1,943.16, and the new value of PR2 is approximately 2,775.95 minus 1,943.16, or 832.79. This is 830 to the nearest 10. For Part E, we note that PR2 increases when the dividend is converted to an additional death benefit because the insurance company makes an additional profit on that additional life insurance business it adds to the original policy. And if the original policy was profitable, and it was, we established that, adding a small clone of it to it should create additional profits. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.